explain about the output voltage obtained from testing of amplifier. We're using calculation method and theoretical method to find the output voltage of an AD620 amplifier. In calculation method, the gain of an amplifier is expressed as the ratio of the output voltage to the input voltage. By assuming gain as 20, the input voltage obtained from simulation is 520 mV. The output voltage obtained after calculation is equal to 10.4 watts. Moreover, the value of output voltage obtained through theoretical is equal to 9.28 volts. Thus, we can conclude that when frequency is equal to 1 kHz, the output voltage for theoretical and calculation is nearly set. Their difference is approximate 1.12 volts. The cost of deviation between the calculation method and theoretical method is because the actual value of resistors, capacitors, and other components are vary from the nominal values due to the manufacturing tolerance and internal noise source. Besides, the physical layout of the circuit, which can introduce additional resistance and inductance that are not considered in the theoretical calculations.
I will explain about the bandpass filter. We set the frequency from 0.5 to 100 Hz. The output voltage will be amplified about 2.5 from the input because of the gain value. As you can see in the table, input that have frequency of 50 Hz has the highest output voltage. This is because it was about the middle of the range that are allowed to pass the filter. The frequency that are outside of the range have lower output voltage. As you can see that 0.3 Hz has 42.4 mV as the output, but as we increase the frequency, the voltage start to increase. At 75 Hz, the output is still high, but it started to decrease because it approaching the frequency that are outside of the range. Increasing the frequency more than 100 Hz make the output voltage decreasing more significantly. As we can see that at 200 Hz, the V-in is higher than V-out.
Hi, my name is Sorfina Bidomor and my numerator is 22115155, and today I will discuss about the result of 20-notch filter. This filter serves the crucial purpose of reduce the signal at a specific frequency, which is the desired frequency is at 50 Hz, which correspond with the frequency of common power line interference. But for our new project, we use frequency at 52.63 Hz because of the several factors that related to availability component in the lab. This is comparison value of the out between three testing frequency, which is 30 Hz, 50 Hz, and 70 Hz, which this is the frequency before 50 Hz and after 50 Hz was applied. At 30 Hz, we can see the output voltage 256 mV is higher than input voltage, which is 248 mV. This is because the filter is actively reduce the voltage at the 50 Hz and the 30 Hz is below than 50 Hz, so the filter is not functioning yet. While at 50 Hz frequency, which is close to the filter center frequency, the input voltage remain at the 256 mV. But the output voltage dropped dramatically to the 48.8 mV. This indicate that the filter effectively reduced the 50 Hz signal, which is crucial for reducing power line interference in ECG signal. And at 70 Hz frequency, which after the 50 Hz frequency, the output voltage is 284 mV and the input voltage is 264 mV. This is because of other than the 50 Hz frequency, the filter reduce effect will decrease. Thank you.
Hi, my name is Coach Eugene. Now I continue the presentation with the whole circuit for ECG signal conditioning circuit. So we can see that the first diagram is sketched from the EZEDA and the second diagram is obtained from experimentally. Based on the diagram, the AD620 amplifier connect to the cascaded high-pass filter with a low-pass filter and give the cutoff frequency between 0.5 Hz to 100 Hz, and then connect to the notch filter, which also called bandstop filter, with the cutoff frequency of 52.63 Hz. And then we can get the more quality output. This is the final circuit for our mini project. First, the pin 3 from the 8620 amplifier, which is input, is connected to the channel 1 of the oscilloscope, which display the input, and connected to the function generator. Then the ground for the breadboard is connected to the ground for the power supply by combining the positive and negative. The orange wire in the breadboard, which is represent the power supply, connecting to the positive polarity of the power supply. And then the negative polarity power supply is connected to the black wire. Lastly, the pin 6 for the amplifier in the notch filter connected to the channel 2 of the oscilloscope to display the signal output for this project.
Assalamualaikum. I am Azza Sofia and I will explain about the final result of our ECG signal conditioning circuit, which the successfulness can be seen by comparing the input and output voltage value. Total up to 10 values of test frequency were used to observe the performance of our circuit, starting from 10 Hz to 200 Hz. The output voltage are expected to amplify when the total gain of the circuit is 17.25. At 10 and 25 Hz test frequency, the experimental result is almost near to the expected result. At 50 Hz, the output voltage is attenuated due to the effect of notch filter. The output voltage at 60 Hz and above is unexpectedly lower than desired outcomes, and we assume it is because of the effect of the notch filter combining with the low-pass filter. The voltage for the test frequency 150 to 200 Hz give the desirable result because at this frequency it is already out of the passband region. In conclusion, we succeed in designing the ECG conditioning circuit with a combination of instrumentation amplifier, active bandpass filter, and active 20 notch filter. The notch filter successfully attenuates 50 Hz frequencies, indicating it is working as intended to remove power line interference. The circuit effectively amplifies lower frequency signals within a reasonable range close to the expected output. However, the attenuation of higher frequencies might be more than what we expect. This could be due to the combined effects of the low-pass filter and other components, which may need further tuning. But overall, from this project, we learned a lot in designing, implementing, and testing a complex signal conditioning circuit for the ECG signals.